everything's based off. And what was that formula?
Y equals mx
And y, b is the y-intercept.
Okay.
M is the slope.
M is the slope. Okay.
B is the y-intercept.
B is the y-intercept. And what was important about the y-intercept or the b?
It helps you find the y.
Okay, we want this, well, at the end, we want the y to be all alone and positive, but what about this y-intercept?
It tells you where it's at.
So it's
the first thing
my,
you graph.
yep, first point on my graph. Every single time. Okay? So it's the first point, and because it's the first point, where is it going to go?
Up.
Up or
Down.
down, right? It can only go up or down because it is a y-intercept. So realistically, in the formula, we should say plus or minus right here, right? Because it could be positive or it could be negative. If it's positive, we go up and put a dot. If it's negative, we go down and put a dot. But it's always going to be on my yellow axis over there. Okay, so we looked at a couple of them, and then we would, this is an easy version as long as you have it in this particular case, meaning what Addie said, we're going to get our y to be all by itself and positive. And then we always want to write the x term first, just so we stay consistent. And that number in front of the x is my slope, and the slope should always be what kind of a number? A fraction, right? And with my fraction, it's kind of like the rise or the run, but it's my y's that are on top over my x's on the bottom. And my y's, again, go up or down, and my x's go right and left. Okay, so we got to remember all that. Okay? Then we showed how to take that information and use it to graph, and then we were into one of the examples at the end, right? So, what was the example we were working on at the end?
X plus 3y equals y.
X plus 3y equals what?
Oh, you said which one?
6. All right, so this is where we were at. We did our first step yesterday in this equation. Remember, we're going to cover up that y part because we're solving for that y. And how did we get rid of x?
Minus x.
We subtracted x from both sides. And remember, if we have the same term but they have different signs, they cancel each other out. And then we had 3y because we just brought it down. And then on the right-hand side, can I take a person and add it to a cow? No, so I just write them out. And again, this doesn't matter which way you write them, but to be consistent, I always put the x part first. So this is where we're at, right? And the question for your homework was, how many times are we going to divide? Remember that? So, how many times do you think we're going to divide?
No, because then the variable's negative.
Twice back there. Twice over here. Only once here.
I said twice.
Twice here.
When you do it 3 times, because you have to divide by the
We're going to do it 3 times. Exactly right. So this is the most important part of this. When you're solving the equation, I want to divide 1, 2, 3 times. So whatever you do to one side, I got to do to the other side. But I want to do it to each individual part of the problem. That's really important. Now we simplify. What happens to my 3's here? When they cancel out in division, though, we get what? 1, right? So we end up with 1 or just y. The next part, we want to include that number as my fraction for my slope, right? So we actually have what here? Negative 1/3 x, right? Now again, remember, when I have a negative as a slope, one negative makes the whole thing negative, but I can put it on the top or the bottom. But put it there, on one or the other. And then we reduce over here, 6 divided by 3 is what? Plus 2. So this is the first time I think we had a negative slope one, right?
Yes.
From yesterday. So we come back over here. And we start looking at our graph, okay? So, with the information that we came up with in our equation, y equals negative 1/3 x plus 2, where do we go to graph it? Up 2, right? We always start with the y-intercept, and it's positive, so we're going to go up 2. From there, then, how do I use my slope?
Down 1. Go to
left.
The top number always tells me to go up or down, right? So first thing you got to decide, where am I going to put that negative sign? If you write it like I had it up there, my negative's on the top. So it's -1 over +3.
You go down.
So I'm going to go down 1 and then which way 3?
Right
To the right. 1, 2, 3.
Negative slope.
Now watch this. So this was us doing -1/3, right? Where m was equal to -1 over 3. Now we're going to do m is equal to +1 over -3. Okay, so let's go back to the original dot that we had right on my y-intercept, and let's use this slope now. So if you were to put the negative on the bottom initially, where does this slope tell you to go? Up 1 and left 3. But in either case, look what happens when I put my ruler down. When I put my ruler down, they're still going to make a line, right? So you can do it either way. How many points do I need? 3, at least 3, right? I can do it as many times as I want though. So down 1, 1, 2, 3. Or I can again go up 1, 1, 2, 3. Either way, we are going to connect our dots. Is that a line?
No, we need
No.
arrows.
Gotta have arrows. Why do I need my arrows? So I'm going to show that it goes on into infinity, right? Because every single line does. So, any confusions on the graphing part? The hardest part for most people is to do the solving part, like we did over here on this problem. This last one right here. Solving to get that equation in slope-intercept form, or y equals mx plus b. So we're going to concentrate on doing some of those today. And then you can have the rest of the time to work.
6.
So, here's my next one. Negative 4x plus 5y equals 10. So let's go through this one together again, and then you can do the next one all by yourself. So again, our goal is for the y to be all by itself and positive, so I'm going to cover up that y part. How do I get rid of negative 4x?
Divide by 4. No, -4.
I'm just going to take it to the other side, so I'm going to take this whole thing by adding 4x. That's kind of the misconception, because yeah, normally we would have done what you guys said, division. But now we just want to move the entire thing, so we're going to add or subtract it. Okay? Same term, but different signs. What happens to my 4x's? They cancel out. 5y equals, and again, I'm going to write my x portion first, and then the whole number. Now again, it wouldn't be wrong if you wrote 10 plus 4x, but we just like to keep it into this form. Okay? Now, what am I going to divide by? 5, and how many times? 3 times, right? So, divide by 5, divide by 5, divide by 5. And what do we come up with? 5's cancel out. Y equals. Can I reduce 4/5? No. Leave it as a fraction. Do not turn it into a decimal. Can I reduce 10/5? Yes.
What's 5 divided by 4? 4 divided by 5.
So we end up with y equals 4/5 x plus 2. What's my slope? What's my slope? 4/5 is my slope. What is 2? My y-intercept. So if I'm going to graph it, where do I start? Up 2, put a dot, then what?
Up 4 to the right 5.
To the right 5. Okay? So here's a question. Let's just say that when I did my first up 2, okay? So we still got our dot right there, right? So let's just say that when we were using our graph paper for the quiz or the test, not that any of you would ever do this, but you started doing your graphing and you really didn't prepare your graph the right way, meaning you didn't leave yourself enough room. So let's just say when we put our first dot here, which was plus 2, right? And let's just say that our piece of paper ran off right here. Okay, so that over there isn't on my piece of paper. So if I was gonna do my slope, I would have went up 4. Oops, 1, 2, 3, 4, and right 5, like you said, 1, 2, 3, 4, 5. But my paper ended right here. So if I would have put that dot there, it would have been on my desk. All right? So I can't do that, right? So when you run into something like this, where you had this slope, but you ran out of paper, you want to take your slope, and this is the only time that you're going to change the sign on both the top and the bottom. Okay? So if I run out of paper, I'm just going to change the sign of both the top and the bottom. So if one was originally negative, it becomes positive, and then it should switch the other one. So if I come back here, how do I apply -4 over -5 from this point right here?
Down to the left.
1, 2, 3, 4. 1, 2, 3, 4, 5. There's my first dot. And now I have plenty of paper, and I can do it again. 1, 2, 3, 4. 1, 2, 3, 4, 5. So what I'm trying to get to is show you here, even if you kind of mess up yourself and you didn't leave yourself enough room, there's still a possibility of doing the problem. But what I'm really trying to get you to do is slow down a little bit and kind of think about your graph and make sure that you have enough room to graph it on your piece of paper and you don't end up on the desk. Okay? Because we really can't have that dot on the desk. That makes sense what I'm saying to everybody though? Okay? So here's the other thing that I want to ask. What happens if when I do my problem that my y-intercept ends up being something like this? So let's just say that when we did our problem, we ended up with y equals 2x minus a fraction. This is going to confuse some of you, okay? But it's my y-intercept, right? So what is that number as a true, maybe decimal or a mixed number? It's 1.5, right? So when I would plot this point, it's -3/2, right? So I'm going to go down -1.5. If my y-intercept is a fraction, don't split it up and say I'm going to go down 3 and over 2 and then put my first dot. It is always on that yellow axis. Okay, so if it's a fraction, you're just going to go down 1.5. That makes sense what I'm saying there?
Yeah.
Okay. So let's look at a couple more and then you can do your problems. So try this one all by yourself. And you don't necessarily have to graph it if you don't want to, but just think about what you would do. So, let's make this a -2y. Okay, so try that one out right there. So we're trying to write this in y equals mx plus b form. Okay? Trying to write this into y equals mx plus b. Yes, sir.
Like the m, or like the slope would be a whole number, would you just make it to a fraction by putting it over 1?
Yes, absolutely. Good comment. And if you get done with that one, let's do this one. So if you get it to where you think it is in y equals mx plus b, then just envision how you would graph it too. You don't necessarily have to do it on your piece of paper, but just understand how you would do that. So again, if you get done with this one, come back and do this one over here too. Did we get them?
I'm still in the second.
All right, so first one. What was the first thing you did?
Well, you subtracted 3x.
Perfect. So I come over here and I subtract 3x. Again, I'm going to cover up that y part. My 3's cancel, or 3x's cancel each other out. I'm left with negative 2y equals. Now I'm going to write the x part first. Plus 2. Again, if you wrote it the other way, it's not wrong, but you might get confused when you're ready to graph. Now what am I going to do?
Divide by 2.
Divide by negative 2. Make sure you do negative 2 and then 3 times. But it has to be in the negative because, like we said at the beginning, we want our y to be all by itself and positive. Negative 2 divided by negative 2 is positive. Why? Negative and negative make this positive, right? Two negatives always cancel each other out. So my slope ends up being positive 3/2. And then at the end, what do I get? Negative 1. How do we do? Okay? Where am I going to go? To graph it.
Up or down.
Down 1, put a dot right on my axis. Then what?
Up 3 and over 2. Or right.
Up 3 and right 2. Up 3, right 2. Up 3, right 2. Or down 3, left 2, down 3, left 2, down 3, left 2. Because I can always put my negatives back on there if I want.
How did I get 3 over 2?
How did you do 3 over what?
2.
And I'm guessing it's that's right.
3 over 2 is right there.
But 1.5 would be x, wouldn't it? So then you'd have to, no, 1.5. So it'd be 1 over 1.5.
This right here is just 1.5x if you do it that way. But don't
Yeah, what number?
She was talking about only the y-intercept if it's a fraction.
Oh, I got negative 1. For the
Yes.
y-intercept, I got the intercept, I got negative 1.
But if you use 1.5, I honestly don't turn any of the
And then I just
slopes into
I just
fractions.
I just doubled it.
2 over 3. Where are we at? Where are we at? There, this one. Yeah.
You got it right.
So you divide by negative 2.
Yeah.
What did you get for the second
So
one?
right here, just put 3 divided by negative 2.
2 or negative 2.
I kind of like did 2
Minus.
time.
Okay.
You
What's
took
that?
3 and
Or 1/2
you divided
minus.
by negative 2, you made it into 1.5. But you put, it's either or, but again, don't use the decimal.
Okay.
Okay? Alright, this one over here. First thing that I'm going to do is what?
Subtract that.
Subtract x, right? Whatever I do to one side, I'm going to do to the other side. My x's cancel each other out. I'm left with negative 2y equals
Minus.
negative x plus 4, right? Really important that I keep that negative with the x. And then I'm going to divide by what?
-2.
How many times?
3 times.
3 times. So again, I wanted to show you this one because I'm dividing by -2. 2 negatives, or a -2 divided by -2 gets me my positive, but 2 negatives make a positive, right? 2 negatives again make another positive. But what's the fraction in front of x?
1/2.
Positive 1/2 x. And then over here, what do I get?
-2.
Negative 2.
Wait,
Plus. I'm just gonna put a plus sign.
what the fuck? Oh, wait, I don't know.
See, I told you.
I was so confused
I-
with what you were
I-
telling me.
I blasted that.
I heard +2, -2,
No.
a million confused.
Someone I said.
Yeah, and don't bring the answer. Okay? All right, everybody good here?
Yes.
We want to do any more of those?
One more.
One more. All right. One more. Let's do 3x. No, let's go -3x minus 4y equals 5. So I intentionally did this one on purpose this way. Make sure you go slow and do what you're each individual part the way that you should. And then we'll actually try to graph this one too. Alright, everybody think they got it?
Yeah. Yes. But it is 100%.
You didn't take 3 divided by 4.
First thing I'm gonna do is what?
Subtract or
Add
add
3x. So that's the first thing that we hadn't seen before, right? Because it was negative, we're gonna add 3x to both sides. So again, the same term but different signs, they cancel each other out. I'm left with -4y, don't forget about that negative sign. And then I'm gonna write 3x plus 5. Everybody good there? Understand why we had to do it that way?
Yes.
Now we're gonna divide by what?
-4 3 times.
3 times again. -4 here with my x and with the whole number. So 2 negatives again make a positive y equals. I only have 1 negative here and I can't reduce, so I'm going to write it as -3/4 x. And then again, why I wanted to show you this one, 1 positive, 1 negative makes the whole thing negative. And I'm going to have a -5/4. Again, this one, maybe you turn that into a fraction, or sorry, a decimal. But we'll talk about that when we're going to graph it. So, first off, how did we do with that part? Everybody okay with this part? Okay, now let's come back over here and try to graph it. So, where am I going to go for -5/4?
Go down 1/4.
So 5/4 is -1.25, right? -1.25, we kind of guesstimate where that is. But again, it's right on that axis. Okay? Now, how do I use -3/4?
Go down
Up 3.
Down 3, Alex says. Now, here's the other thing while you're doing this. So remember, we're in between, right? We got to be in between every single time. So when I graph it, I'm going to go down 1, 2, 3, and over 4. 1, 2, 3, 4. I still got to be below that little black line. Then I'm going to go 1, 2, 3, 1, 2, 3, 4. Now, Grace said she did +3 over -4, the same thing though. 1, 2, 3, 1, 2, 3, 4. Just remember, I'm a little underneath my line.
So you just keep the negative one at the bottom.
You can put the negative wherever you want.
So you, okay, but I was dividing.
Yes. And then either way, my dots should line each other up. And don't forget your arrows. Okay? But look at how my little dots are always underneath my coordinates. Right? Because my original one was a little under. Make sense?
Yeah.
Everybody okay with that? So you're gonna
Okay.
you'll have a lot of practice on this, trust me. Because this is one of the things that is really important for whatever you do in math the rest of your lives. Okay? So here's your assignment.